Untitled Trigonometry. First one is take a look at the section 4.1, radian and degree measurement. So the typical conversion is 2 pi equals to 360 degrees, right? And this is radian measurement, this is degree measurement. So from there we know that pi equal to 180 degrees. Okay, so this is very important conversion between the radian and degree measurement. So now we're going to learn how to describe angles, the structure of the angle, radian measurement, degree measurement, use angle to model and solve real life problems. Okay, angle first. So back in the ancient Greek, come up with the trigonometry. And when they first come up with trigonometry, they used to measure the sides and angles of any typical triangle. So they call that measurement of triangles. Initially, trigonometry deal with the relationship among the sides and the angles of triangle. An angle is determined by rotating a partial line. Rate, it's what we know, half line or partial line about its endpoint. So that's first one. Let's take a look at how the angle was formed. So you start with the vertex. So vertex is like the initial point. We have initial sign and terminal sign, and you rotate it. You're going from initial sign to terminal sign counterclockwise. Then you form an angle. You could call this angle alpha. Okay. So the angle needs 3 elements: vertex, initial sign, terminal sign. Okay, for any angle. So the vertex is the initial point, the end point, initial point of the angle. So if you put into a Cartesian system, this is what we call Cartesian system. So initial signs always stay on the x-axis, on the positive side of x-axis. And the terminal side, it could be in either one of the quadrant here. We have 4 quadrant. So x-axis, y-axis split the region into quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And such angle is in a standard position. We call this a standard position of the angle. And the positive angle is formed by rotating the angle counterclockwise, meaning this is a positive angle right here because it's rotating counterclockwise. And if you rotate clockwise, you're going to get negative angles. And we can use Greek letter alpha, beta, or theta to represent the angle. Also, we can use uppercase letters A, B, C, D, E, F, whatever letters you want to use to represent any angle. So if you look at this angle in this first graph, angle alpha and angle beta have the same initial sign, terminal sign. And we call this coterminal angle. So angle alpha and beta are coterminal angle. Also means that they are the same, right? They are equivalent angles. Similarly here, alpha equal to beta. By rotating the angle alpha one more cycle, one more revolution, they come up with another angle. Then they are equivalent as well. Radian measurement, usually we know that a typical angle could be expressed in the radian form, and typically one revolution, one cycle is equal to 2 pi. Okay. Now let's take a look at it, how we measure the angle, any angle. A radian measurement, again, you're using the central angle theta here, and the radian measurement, you measure the arc length. This is arc length right here. This particular part is called arc length. Arc length is formed by the angle and also the radius. So arc length S equal to R times theta. And theta must be expressed in the radian form. So 1 radian measure of the central angle theta that intercept arc S equal in the length of the radius of the circle. So we find the ratio angle theta should be expressed as arc length over the radius. Okay. S represent arc length. R represent radius. And here theta is expressed in the radian form. Okay. And typically circumference of the circle is equal to pi r units. And then it depends on the radius. You may have different circumference based on different circle. So again, 1 full revolution meaning 1 cycle counterclockwise, arc length S equal to 2 pi r. You also call this circumference. It's like perimeter for any like geometrical shape or like geometrical shape, right? Circumference is same thing as a perimeter. So 2 pi, if you remember that pi is approximately equal to 3.1415. So if you replace pi with 3.14, then 2 pi is equivalent to 6.28 radian. So basically, if you look at it, a typical revolution or 1 cycle, a full cycle, will have 6.28 radians. So there's 1 radian, 2 radian, 3 radian, 4 radian, 5, 6, and a little bit more, right here. 0.28 radian, right here. That completes one cycle. And also we know that one full revolution is 2 pi radian. So then half a revolution will be pi radian, okay, because half of it. 2 pi over 2 becomes pi radian. And quarter will be 2 pi over 4, pi over 2 radian. And 2 pi, 1 over 6 revolution is 2 pi over 6, 3 pi over 3 radian. Now let's take a look at some common angles, like pi over 6, that's also equivalent to 30 degrees. Because pi, remember pi equal to 180 degrees. So replace pi with 180, 180 over 6 gives you 30 degrees. And then here it's a 45 degree, pi over 4 is 45 degrees. Pi over 3 is a 60 degrees. Pi over 2, 90 degrees. And then half cycle will be 180 degrees. And then 2 pi, that will be 360 degrees. Okay. So that's a equivalent radian measure and a degree measurement. And also one more thing I mentioned earlier, you see x-axis and the y-axis right here in the Cartesian system split this area into 4 regions. Quadrant 1 is between theta greater than 0, less than pi over 2. Also, we can say that theta is greater than 0 degree and greater than 0 degree, less than 90 degrees. Okay, second quadrant number 2, again, we're going counterclockwise. Quadrant number 2, the angle is between pi over 2 to pi. Also, you can say that 90 degree to 180 degrees. Quadrant 3, theta is greater than pi, less than 3 pi over 2. Putting degree measurement is 180 degrees and 270 degrees. And the quadrant number 4, theta is greater than 3 pi over 2, less than 2 pi. So theta greater than 270 degrees, less than 360 degrees. And that gives us 4 different quadrants, and then also the related angles. And two typical angles we need to pay attention. Acute angle is angle between 0 and 90 degrees, or between 0 and pi over 2. Theta is greater than 0, less than 90. We call this acute angle. And an obtuse angle is angles between pi over 2 and then pi. You can also write it as theta greater than 90 degrees, less than 180 degrees. And this is obtuse angle. And two angles are coterminal if they have the same initial sign and terminal sign. For example, pi over 6 and then 13 pi over 6 are coterminal angle because they share the same initial sign and terminal sign. So basically, if you're adding pi over 6 by 2 pi, adding one cycle to it, and pi over 6 plus 2 pi, that's 12 pi over 6. Combine like terms, you get 13 pi over 6. That's how we can come up with a coterminal sign. So if you want another coterminal sign, you can do pi over 6 adding 4 pi, meaning adding 2 cycles. That is pi over 6 plus 24 pi over 6. And that turned out to be 25 pi over 6. Still, this is also coterminal sign with a pi over 6 and a 13 pi over 6. Yep, by adding and subtracting 2 pi, right? That's one side, one revolution demonstrated from the previous. You're subtracting 2 pi, you also end up with a coterminal angle. And general coterminal angles for pi over 6 will be 2n pi. You could plus minus 2n pi, right? To be more precise, you have infinitely many terminal angles, and where n is an integer. So now that going back to the previous example, for the positive angle 13 pi over 6, if you're subtracting 2 pi to obtain the coterminal angle, you get pi over 6. 13 pi over 6, 2 pi, that's 12 pi over 6. If subtracted, you get pi over 6. So they are coterminal. And for the negative angle, negative 2 pi over 3, adding 2 pi to that, so negative 2 pi over 3. 2 pi and that's 6 pi over 3. And you combine them, you get 4 pi over 3. So the negative 2 pi over 3 and then 4 pi over 3, they are coterminal angles. Same initial sign, same terminal sign. And also, let's take a look at complementary angles. Two positive angles, alpha and beta, are complementary if their sum is pi over 2. So to be simple, make it simple, alpha plus beta equal to pi over 2, or alpha plus beta equal to 90 degrees. They are complementary. And supplementary angles, if you're adding alpha and beta, you end up with a pi. Or when you add up alpha and beta, end up with 180 degrees. So they are supplementary angles. Okay, just two definitions, and then this is graphical aspect of the complementary angle and then supplementary angle. So now let's take a look at the degree measurement in more detail. A second way to measure the angle is degrees, denoted by the symbol theta. Angle, right? Symbol degree. So this is degree symbol. 1 degree is equivalent to rotation of 1/360 of a complete revolution about the vertex. So this is the typical popular angles. We use 30 degrees, 45 degrees, 60, 30, 60 degrees, 90, 120, 135 degrees, 150 degrees, 180 degrees. And the all of those angles are popular angles. And the full revolution is, one full cycle is 360 degrees. Half of it will be 180 degrees, quarter will be 90, so on and so forth. So we know that 2 pi radian is equivalent to 360 degrees. That means pi radians is equal to 180 degrees. This is very important conversion formula between the degree measurement and then radian measurement. So 1 degree is a pi radian over 180. 1 radian is 180 degrees over pi. Okay. Just according to this conversion formula. Now to convert degree to measurement to radian measurement, degree measurement to radian measurement, multiply degree by pi over 180 degrees. To convert radians to degree, multiply radians by 180 degrees over pi. I'm going to show you another method in a bit, but yeah, definitely this is a more simple conversion formula we need. Pi radian equal to 180 degrees. So mentioned that earlier, pi over 6 is 30 degrees, pi over 4, 45 degrees, pi over 3, 60 degrees, pi over 2, that's 90 degrees, pi, that's 180 degrees, and 2 pi, 360 degrees. Now theta equal 2 implies, if you don't see degree symbol here, then it must be a radian, right? I'm talking about radian, but sometimes you may see 2 degree. That means this is 2 degrees, theta equal to 2 degrees. So this symbol makes a big difference. Now let's take a look at how we convert 135 degrees to radian measurement. So one way is multiply by pi over 180. Another way is set up proportion. So we know that pi radian equal to 180 degrees. Now we don't know, we want to figure out equivalent degree radian measurement for 135 degrees, but we don't know how many radian that is. So assuming x radians, so you cross multiply and then solve for x. So it's 180 degrees times x equal to 135 degrees times pi. So dividing 180 degrees from both sides of the equation, and get x equal to, reduce it, you get 3 pi over 4. So 135 degrees is equal to 3 pi over 4. Okay, so that's equal to 3 pi over 4. Okay, so 2 methods, you can use either method you like. So now similarly, 540 degrees is 540 degree times pi radian over 180 degrees. Or you can also use the proportion method, meaning we set up proportion using the radian over degree. Now we have 540 degrees. How many radian? We don't know that. So cross multiply and then solve for x, which is radian measurement. So dividing 180 degrees from both sides of the equation, the x value equal to 3 pi. So an answer turned out to be 3 pi. 540 degrees to 3 pi radians. Okay. So anytime you see pi, that tells you it's a radian measurement. Okay. Let's take a look at couple of the applications, right? The first one is arc length. So let's say this is a full circle right here. Arc length is typical of partial circle, meaning it's part of the full circle, right? Let's say you're looking at the arc length from here to here. So you're looking, this is a typical arc length. Okay. So the circle of radius r, central angle theta, intercepts the arc of length s. So arc length s equal to r times theta. And the theta here must be measured in the radian measurement. Okay. Because the circumference is expressed, circumference of the circle for 2 pi r. And we know that 2 pi here is a radian measurement. Now we know that arc length is partial circumference. So that means it's the theta must be expressed in the radian measurement. Okay, let's take a look. Let's say the radius for this circle has radius 4, and then the central angle is 240 degrees. You want to find an arc length. So S equal to R times theta. And theta must be expressed in the radian measurement. So theta equal to 240 degrees. We want to convert it to the equivalent radian measurement. So using similar proportion, pi over 180 degrees, pi equal to 180 degrees. I get 240 degrees. We want to know how many radian that is. So 180 degrees times x equal to 240 degrees times pi. And dividing 180 degrees from both sides of the equation, x equal to 4 pi over 3. They both could be reduced by 60, so we get 4 pi over 3. So arc length radius 4 times 4 pi over 3. And this should be 16 pi over 3. We know that the unit is inches, so 16 pi over 3 inches. That's arc length we're talking about. Yeah. There's detailed solution here. I just showed you earlier. If you want to turn it back to, you can replace pi here with approximately 3.14, 196, right? You put it to the calculator, calculator will give you this input, this result. So the arc length has the same unit as the radius. Okay. Also, I want to take a look at area of the sector of the circle. Area of the sector is equal to half times r squared times theta. Again, theta must measure in the radian measurement. Okay, because area of the full circle is pi r squared. Okay. And then half theta, theta here must be the radian measurement. Okay. The sector of the circle is region bounded by 2 radians of the circle and their intercept arc. So if you look at this, assuming this theta is equal to, let's say, 75 degrees, right? Theta equals 75 degrees. If you want to find out the area of this sector right here, so area of the sector equal to half times r squared times theta. So again, we just basically need to convert in 75 degrees to a radian measurement. So we do pi over 180 degrees equal to x over 75 degrees using the conversion formula. Now let's convert to the radian measurement. So 180 times x equal to 75 degrees times pi. Now dividing both sides of the equation by 180 degrees. Okay, so cancel that. X equal to reducing. Both could be reduced by 15, so it's 5 pi over 12. 75 degrees equal to 5 pi over 12. So go back here. Assuming radius here is equal to 2, right? 2 units. So it will be 2 squared times 5 pi over 12. So it will be, simplify that, it's half times 4 times 5 pi over 12. Reduce it is, again, reduce further. The result is 5 pi over 6 units, right? So if this is 2 inches, and the area of the sector here must be square inches. Square inches. So 5 over 6 square inches. Okay, so that's how you find out the area of the sector.